Right, so in this picture, my friend from Amazon is comparing three scenarios. So what happens when you have traditional data center, what happens when you have virtualized private cloud, and what happens when you have public cloud. So my question is, why in traditional data center your upfront cost is more than the private data center? So traditional means they're not using virtualization. They're using the old way where you just buy the servers and install your operating systems and an application of that. So why would you think the upfront cost in a traditional data center will be higher than the virtualization enabled data center, and why it is zero in the public cloud? In the traditional data center, as he said rightly, you're not using virtualization, so based on what application, what operating system environment you need, you have to buy that many hardware for all those application footprint, and then you just end up buying more hardware as compared to in the virtualization, where on the same machine you can run a Docker container with Ubuntu, a Docker container with Windows, a Docker container with Linux, Mac, whatever you want. So actually, you can do more heterogeneous application consolidation in a virtualized environment as compared to non-virtualization environment. Why do you think the variable cost is high in traditional data center as compared to virtualized data center? Variable cost is, again, power, space, your admin stuff. So because you have more hardware, you need more of all those things. You need more power, more cooling, more stuff managing it as compared to the private one because it's virtualized. So also, managing as an IT engineer a virtualized infrastructure is much more agile and easy as compared to a non-virtualized, because you get a lot of tools, you can manage a lot of things at the software level than actually debugging at the hardware level. So that's why you have a very less variable cost. And of course, as he said rightly, in the public cloud, you're not buying anything, you're not setting up anything, so you don't have any upfront cost. What you actually have is the variable cost. So, but that goes around, this variable cost is fundamentally different than what goes in those two. So, understanding those are very important when you want to compute your TCO matrix, because although they have the same word, variable cost, but the what parameters impacts the variable cost is different across which cloud deployment model you're using. Right. So, as I said before, if you're using on-premises thing, you have all this cost that builds into your ongoing cost and variable cost. But if you use public cloud, you just don't spend any money on that. You just start from day one. Right, now this comes to the interesting graph. So if you are a company, so this one is your current application cost. That is, say, it's traditional data center or private virtual data center. But one of you went to that company and said that you somehow motivated them to migrate the application to the public cloud, and they did that. Why you think the cost is initially high for migrating public cloud, but at some stage it comes down, and you at some stage get really cheaper for you over, say, M12 or something? What could be reason for that? Why initially, when you start using the public cloud, your cost goes high, but slowly over the period of time, it goes lesser and lesser? What could be reason for that? Someone from here?
Do you overcompensate with kind of what you need, and then you can refine it, capacity?
So that's one of the point. Why the migration cost is very high? What we see here is the migration cost, actually taking something from here and putting inside the Amazon data center. Yeah, I'll come back to you. Maybe someone from here get them thinking why the migration cost of taking some software from a private data center and putting public cloud is so high. What could be that? So cost of moving data, cost of moving your virtual servers. For example, you are running certain operating system on your private data center that may not be supported there, so you have to port your code. A lot of legacy codes are there. So there's a lot of background thing you have to do before your application cluster can start running in the public cloud, and then you may need new engineers to even to repackage your application in a way that runs on the public cloud. Yeah, so that may the reason, that are the factors that contribute to the migration cost. So why thing is coming down over the period of time? So it was constant, but in some cases you might end up paying less as well. What would be that scenario? What is the economics behind that? Yeah?
Sort of, feel like over time the machines become more cheaper to maintain.
Right. So something like that. So what Amazon does, it keeps changing the price of the machines and the price of the data storage. They call it as spot pricing. So if you're a smart optimization engineer, you can always bid for cheaper machines and cheaper data storage, and that's why you can bring it down. So one point to note here is this cloud is not about you just take application and keep it running. If you do that, then you will get the straight line, a constant. But if you really want to save money and benefit from the pricing policy of cloud provider, you actually have to be very agile and dynamic and always have to bid for those spot pricing and bring your leasing costs down as you go. So you really need those real-time algorithms to be able to track the prices, what Amazon and Microsoft are offering, and based on that decide how you want to switch your hardware configuration, your VM configuration, data configuration, so that you save the cost. So you obviously that algorithm is not ready to use, so that's where you as an engineer have to program those algorithms so that for your company you can reduce the price. So in lecture 3 or 4 we will show you one of those algorithms how it could be done. So one of the study from Amazon says that the most contributor to their cost is upgrading the hardware, that is almost 32% of the TCO. Then upgrading the 20% cost goes to data center facilities like cooling, power, space. Storage hardware refresh, 25% of the cost. So this survey was done by Amazon Web Services guy by studying the in-house infrastructure of a big bank that use their own data center. So as you see here, as we discussed, most of the cost goes into the storage and the server hardware, and then if you optimize that on the public cloud, as you see in the other graph, you can bring your cost really down over the period of time. Right. However, having said all these good things about public cloud computing, they also have a problem. The main problem they're having is most of the servers in the data center is only 50% utilized. Another 50% time they are doing nothing. Then how do you think the Amazon guy has become the richest guy in the world if 50% of time no one is using it? So it shows that in Amazon data center, 50% of time no one is using any server, but still the guy who owns Amazon, Jeff Bezos, he is the richest guy in the world. So what could be the reason for that? He's making enough money in the other 50% time that people are using it. So see, even with Amazon with millions of users, they have this under capacity problem, right? Most of the time it is not utilized 50%. So what they really need to do is they need to come with the smart algorithms for pricing in a way that in those 50% of time when people are using his infrastructure, they are able to make enough money and enough profit so that they can sustain this business model. So that's where the optimization again comes into picture from cloud provider perspective. So we always have to think the optimization from two perspectives. One is the cloud customer perspective, like me and you. If we want to use the cloud provider, our goal is to save money, right? We want to save how much we want to pay to cloud provider. That's our job. So this optimization algorithm is different from the optimization algorithm which should be implemented by an engineer sitting in Amazon Web Services who wants to maximize the profit for his vendor like Amazon. So they need to come up with certain kind of pricing policy in such a way that they set the price of their storage and the server and their networking equipments in such a way that in spite of being used for 50% time, they always make a profit so that they can sustain the business. So as you see, based on who you are, where you are, either you're a cloud consumer or cloud provider, your optimization goal, your pricing economics model changes. And that is very, very important to understand. So what they did is, so how many of you know about 3-tier web application architecture? No? So just to give you a background, most of the application like say Gmail or any browser-based application where you are served with HTML pages, where you see the content, or JavaScript pages, they are based on this 3-tier architecture. And the main components of this 3-tier architecture includes somewhere where you can store your data. That would be the database services. So in this instance, they're showing Amazon RDS. So Amazon RDS is a managed database service offered by Amazon Web Services, and in this case they implement both MySQL and SQL Server, but it's managed service. So in a 3D web application, we have 3 layers. One is the web server, one is the app server, and one is the database server. In the app server is where you do your application logic, where you do your computation. For example, if this was a book application, bookshop application, so the app server will help take the queries from you about which book you want to buy, which book you want to search, and take that queries and then fire those queries on the database layer and give you the catalog of them. And what is the function of the web server layer? The function of web server layer is to, once the computation is done by the database layer and the app layer, it embeds all the information in the HTML page, renders that page, and presents to you on the browser. So this is how the standard web application works. And then in this picture you see load balancer. So load balancer job is to be able to distribute your HTML page request or bookshop search request across multiple instances of web and app server. So obviously, as you say in this picture, the goal of this load balancing is different from load balancing across the network switches, right? This is you're doing at the level application, but if the same load balancer is put in the say factory topology, it's going to be different because they don't care about that. So why I put this example, it's important to understand even for a simple concept like load balancing, it differs on which layer you're working. So if you're working at the level of the application, this load balancer is only caring about distributing the traffic across 2 instances of web servers. But the same load balancing concept, if I'm talking in terms of network switches, its goal is different. Its goal is to distribute the network packets across 2 switches in an equal manner. And it doesn't care that packet is for web server, app server, DB server. So based on what kind of level you're working on, your load balancing algorithm will change. So this is where the cloud computing gets complicated. Simple concept like load balancing changes based on at which layer you are working on, which kind of hardware, software application you're dealing with. Right. So what they did, Amazon guys, they took this standard 3D application and they did an experiment, as you said, the benchmarking experiment, and they figured out how much will it cost to run this application in a private cloud as compared to the public cloud over 3 years with a fixed set of number of users per second. And based on that, they decided based on how many users going to access your books of application, you need a fixed number of virtual servers, you need fixed number of storage, fixed number of database servers. And based on that, they did experiment and see over the period of 1 to 3 years how your cloud hosting costs are going to change. Right. So this is so what they said based on that application model and based on a forecasting model. They use machine learning statistics that says that okay, on your 3D application you will not get more than 10,000 page views or 10,000 users per day. So given this 10,000 users per day, they anticipated that you need 3 web servers, 3 application servers, 2 cache servers, 1 load balancer, 100 gigabyte of storage, and 300 gigabyte of data transfer every month. Given these requirements, they said if I run this whole application stack on-premise, it will cost you over 3 years almost $100,000. However, if you choose to run the same application on Amazon Web Services without a price drop, it will cost you $38,000. But if you are smart and you take advantage of this dynamic spot pricing, you even bring the cost to $26,000. So as you see, as compared to running the same application stack on-premise as compared to the public cloud, how cost changes. So for example, when you finish your degree and you go for a job and you are a cloud consultant, your client will ask you to do such analysis for their infrastructure. And the starting point for you that way to figure out the left-hand side of that, and based on that, you have to come with this graph and know that, and tell your client that what's going to happen if you're going to run the same application infrastructure in-house for the next 3 years, and what happens if you use the public cloud. And based on this analysis, they'll make a decision whether they want to go for private cloud, public cloud, the hybrid cloud. So this kind of analyses are really complicated, but it's just not about the cost, because you have to know what kind of hardware and software you need to run the infrastructure, and that is also not fixed because it depends on how many users are using a service. For example, instead of 10,000 page views, if you had 100,000, these all will multiply by 10 times and all the cost will go 10 factor up. So these all things has to be in your calculation, and only way to do that is by doing benchmarking and performance modeling. Of course, I keep talking about that word. We also teach you how to do the benchmarking, and it's also part of your coursework as well, on some small scale. But yeah, that's why as a cloud engineer or cloud consultant, you need to know how to benchmark certain application, how to determine how many services you need, and then need the ability to convert that to real economic cost. Because ultimately, the main driver for using public or hybrid cloud is the cost factor, which is just not a number. It depends on other thing, that is your application architecture, based on how many users are using your services, based on how much hardware you need, and how the pricing is going to change. So you need some intelligence, some algorithms to bring all these things together and come up with this graph. Okay. Right. So for example, you go to certain client like Tesco, NHS, and they will give you something like this. So this is how my utilization looks like. So someone will say my utilization is spiky. Someone will say we have sometime peak, sometimes zero, sometime average. Someone will say it varies like a cyclic curve. And based on that, you need to determine which of these curves can best fit it in the public cloud or private cloud or the hybrid cloud. Right. So why you think for the public cloud you get this kind of curve? Or why this kind of curve is better fitted for the public cloud? Because it's variable, very variable, right? You never know when is your peak, and your peak keeps changing. So if you want to host this kind of workload on your private cloud, you always have to find the max peak and then buy for that, and then that's where you make your losses. So for this kind of workload, if you host on the public cloud, then your demand, resource, and payment all will be correlated with a high probability. But if you want to provide the same workload on the in-house ID, because you're provisioning to the peak load, your cost just goes high, because you need to find the peak in your demand, and then from there you will spend a lot of money, and then it will not be utilized, and you will make a lot of loss. So the first step in determining whether to use public cloud or hybrid cloud is to know your demand curve. How much traffic, how many users are using your application, how much data you need to store, and how much throughput and response time you need to provide to the users. So that will be only be determined based on your demand curve. Right. So what impacts the demand curve? So if you take example of Twitter, right? So now in UK we have time of elections. So every party are tweeting. Labour Party is tweeting, Jeremy Corbyn is tweeting, Boris Johnson is tweeting, and then there's a lot of activities. So so normally maybe in few months Twitter will release some data saying that during the UK election the total users of Twitter was 5x or 10x times than the normal. For example, during election of Obama, the total Twitter users around the world was 5x than normally happens around those Twitter handle. So this events, the time of the year, or these events like election or someone getting an appointment, these are the main factors that affects your application demand. And based on these factors, you need to determine how my peak, average, and minimum workload is going to vary. And based on that, you need to decide whether for that workload either public cloud is good, or private cloud is good, or hybrid cloud is good. So obviously, once you determine your demand curve, then you need some mechanisms to determine, to compute the cost, how much it will cost me to run these services in private cloud as compared to the public cloud, or as compared to the hybrid cloud. So we will go into that now. Right, before we go there, if you have a curve like this, it is very safe to say you just go for the public cloud because you have a rapid progress and you can use pay as you go and the elasticity of public cloud to rapidly scale your application services. But the problem happens when you have the bursting of your workload. Sometimes you get the peak, someone get the minimum, someone get the peak. So in this kind of workload, what will you recommend to your client? So if someone is experiencing this kind of workload, what kind of model will you recommend? So the first one is quite clear. It's rapidly growing, so public cloud is the best because you can keep adding your VM storage and network on the fly. But the second one is, see, your peaks are always changing, but there's one thing which is not changing, which is what? The minimum workload, right? So what will you propose someone who wants to move to public cloud, which model to use, public, private, or hybrid?
Hybrid.
Hybrid. And why would be that? How will you go about that?
We should be fine with providing enough resources for the minimum, and when the peak comes, we can get support from public cloud.
Exactly. So you always provision for minimum workload in your private cloud, which is a fixed, it's not changing, and whenever the peak comes, you migrate those workloads to the public cloud. But the question is, how do you do that? Is it that easy that when the peak comes, you just scale it up? What goes behind that? Software, right? And that's again, you need a lot of algorithms to be able to monitor your demand in-house, what is your demand, your minimum demand, and whenever it peaks up, use some kind of machine learning technique to extrapolate what's going to be your peak load, and based on that, you scale that and decide when to burst into the cloud. And it's not only that, you might burst into the public cloud at this step, but however, as you say here, the load comes back. Then you need to cut down your infrastructure. So you need the algorithm to be smart enough to again descale. So this is the main reason behind public cloud computing, this elasticity, that you can scale at a point on this workload, but when your workload goes down, you can always bring back infrastructure and you descale. So that's why it's called elastic. So it's not, so like in the first graph, it's always one-way scaling, you just keep scaling. But in the second one, it's not one way, it's both ways. You have to first scale, and then you have to descale, and then on the third step, again, you have to scale. Right. So if we follow this forecast demand of a constant line, so what is the problem with that? The problem with that is, if my demands pattern are here, I lose my customers, right? And if my demand patterns are here, then I waste my resources. So right, I somehow need a certain way to manage my resource demand and supply, so that neither I waste my capacity nor I lose my customers. So that's the balance you need to do as a cloud engineer, as a cloud administrator, so that your company keeps in business and they keep making a profit. So now, going to that, we are now looking into how can we determine when to use public cloud, when to use private cloud, and when to use hybrid cloud. So the first thing is, the first equation we want to see is when to use public cloud versus private cloud. So if CD server is the unit cost of setting up and running up your private data center, and C server is the cost of using public cloud server, if the cloud cost is less than CD server and you are happy with the security, performance, management parameters, then you are advised to use the public cloud. Is this a correct hypothesis? So if your cost of using public cloud per unit of time is less than managing your in-house data center, and at the same time it is satisfying your security and performance needs, it is safe to say that you should use the public cloud. Because first of all, it's cheaper and it is meeting your constraint on security and performance. So if it's less, then the decision is straightforward. If they are equal, then also the recommendation is, if it meets your security and performance, you still use the public cloud because it will save you a lot of hassles in managing and buying the infrastructure. However, the problem begins when your cloud cost is more than your private data center cost. So what do you do in this case? Which is always the case if you consider on per unit of time. So if this happens, what could be your approach to solve this problem? If the C server cost is greater than the data center cost, how should you go about solving that problem? So the thing with the cloud is this. So cost of running one server on T nodes is same as cost of running T hours on one node. This is how the public cloud pricing is. So either you run each 10 servers for 1 hour each of the same configuration, the cost will be same as running for T hours on one server. So this is the fundamental way the cloud costing is done. So you can compute the cloud cost as servers across the time. Doesn't matter how many servers you use because it's the same both ways. Right. So as you said, so we use the cloud when the average load or the cloud cost is less than the peak load and the data center cost. So you can use this equation to figure out when the cloud is cheapest and data center is the cheapest. Of course, to lead to this decision, you first need to know how much it will cost per unit of time to set up your own blade servers that you buy from Dell or any other vendor that will fit into CD server. Then how much will it cost to buy something, lease something from Amazon or Azure on per unit time that will fit into your C server. Then you got to get your workload log from your existing IT infrastructure and determine what is my peak resource demand and what is my average resource demand. Based on that, the assumption is that over the period of time, because of this dynamic elasticity, you always end up running the average load on the cloud. So you only pay for the average infrastructure as compared to the peak on the data center because you have to provision for the peak workload. And then if your average across the cloud cost is less than peak, then you can still choose your public cloud to run your thing. So this equation, if you know, you can always compute when cloud is cheapest, when data center is cheapest. And in the exam, you could be asked this question, and you can be asked in which scenario. So I might give you average and the peak load. In which scenario cloud is cheapest? In which scenario data center is cheapest? So given that equation, can you solve this one? That's fine. So given this average peak load and this cloud cost, so what should be the cost of data center? So it's cheaper to buy than use a cloud. So just using this equation. And we'll try. So we have average load, we have peak load, we have cloud cost. So what should be the data center cost per unit time, per unit server, so that it's cheaper to host your application or to build your own data center as compared to moving the public cloud. So what should be CD server? You have been given average, peak, and this. Anyone? So yeah, so for you it's from exam perspective, it's very important to understand this relationship between average load, peak load, and the cloud cost and data center cost. And you could be asked an exam question of worth 10, 15 marks around that. Of course not exactly this. So if you go to Blackboard, you can see my last 3 exam papers here have been asked this question in different ways. So you need to understand the relationship. Okay.